Good afternoon. I want to talk a little bit about what we at Fisher Valves are doing, trying to bring IoT type capabilities, functionality into control valves, into the control valve space. So for us, this is still kind of an early on project. We haven't got a complete and total solution yet, but it is something that we are starting to deploy and have a few years experience with our customers. So I'll tell you a little bit about how we got there. One thing I'll admit to as well is, we actually didn't get into this with the intent of developing a service for our customers. We actually were interested in collecting more data on control valves. So I come from the R&D function within Fisher. We work in a test lab. We test and break valves for a living. That's what we do. But what we find out is no matter how many things that we look at in the lab, these failures never happen exactly the same way as they do in the field. So for us, it was initially about collecting more data from the field and getting some more realistic information. Coincidentally, or maybe not coincidentally, some of our other colleagues were also looking at remote monitoring capabilities for assets that our customers would have, and this seemed to be a natural fit. So it's actually one that we've probably got the most experience with now within our organization. So just a real quick background on Fisher. We do manufacture control valves, and they are widely varied in the size, the style, the application. But mostly control valves is what we make, with also some focus on the valve controller, or the positioner that we call it, and the software that communicates to that. Those are kind of the enablers of what we'll talk about today with IoT. A lot of people in this conference would be familiar with this architecture, but this is generally how control valves are applied and connected in the field. They are connected to a distributed control system, and the devices are connected to that, whether wirelessly or wired. And one of the big limitations here, there's actually really two limitations that really got in our way from an IoT standpoint. So I won't get into all of these, but two of them are, one, there's typically no internet connectivity or very limited. So what that means is that this control level network right here sometimes is completely air gapped to the internet. In a lot of cases, there's just no connectivity in the field. There are some cases where it is, but there's strict security around that. The other big deal is that most of our valves, probably 85%, are operated on the HART communication protocol. They're 4 to 20 devices, which means that they have very limited power and processing capability at the device. So all the smart things that we want to talk about, other sensing, processing, all this capability, there's only so much space in that device. So we've got to be a little bit careful about how much we can push down there. Obviously, we'd like to do as much locally as possible, but in some cases that's difficult. So those are two big challenges based on kind of the current state of the architecture for our customers. So some of the challenges that our customers run into, just like to explain some of those. Our customers really value reliability, availability, uptime. The most important thing is the plant keeps running. They need to make sure that nothing happens. From a valve standpoint, that means no valve failures, or at least no unpredicted valve failures. One of the big issues we run into, though, is that our customers buy from us diagnostic capabilities, software, instruments that have added capabilities, but they often don't get those products configured or implemented properly to get the value out of them. So that's a very common issue. So it's not that they don't necessarily have the ability to understand valve diagnostics or what it takes to keep that valve in good shape. They just got too many things going on, not enough time, and frankly, our customers are good at refining oil or making paper or chemicals, those types of things. They don't have the time or the expertise to become the real valve experts. So that's one issue. So a lot of the diagnostics, the software that we provide is perceived as a little too complex. Well, one of the issues with trying to bring IoT into all this is that we're actually planning to make them more complex. We want to put more sensors on the valves. We want to put more technology into the valves, and we think that provides a lot of value. But again, it further distances what our customers can actually get from that data. We're really good as engineers at throwing more data, more charts, numbers at them, but it doesn't necessarily translate into what do I have to do to maintain the valve or to keep it operating properly. The other thing, and like I say, kind of a summary there, is most of the end users just have not fully utilized or realized the value of the smart instrumentation, the diagnostics, the predictive technologies, the things that we've built in for quite some time. In fact, for at least 15 years that I've been involved, we've been talking to our customers about, you got to implement these tools, set them up properly, configure them properly, and probably change your culture, change your work practices a little bit to get the most value out of them, and that just doesn't take place. So we think that we have an ability to get in there and help fill that gap a little bit. So how can we create value for our end users in the process industries? We're finding that our end users are becoming more open to new services or other types of services. And as the OEM, we should be able to bring our expertise around control valves, especially the valves that we produce, to help provide some of those gaps. We also see that our customers are desiring these component level predictive indicators. A lot of our alerts and alarms that we have today pop up and say something's wrong. They're fairly general. They don't necessarily pinpoint you to a problem. We think we should be able to get down to component level issues, not just an alert, but you have an alert because you have high friction because your packing is failing. Getting down to that level of detail really brings a lot of value for our customers. The other thing the end users are asking for, and I might have mentioned a little bit on the last slide, is really less graphs, less data. Just tell us what needs to be done. Kind of, what does it take to create a work order and actually address the problem, get the valve fixed or maintained properly. They would like subject matter expertise help when needed, and just in general, looking for anything that can help lighten their workload. They got too much to do already. Let's make it easier instead of just throwing more tools or more numbers or more graphs that they don't fully understand. So as technology providers, we think we have an opportunity to fill these gaps, and that opportunity really creates value for both sides. Delivers value for the customer, but also for us. So we started out simple with our remote monitoring strategy, and like I say, we started out just trying to collect more lab data, to be quite honest. And what we were doing is a couple different methods of getting data from the end user up to cloud-based storage. And in some of those cases, it was secure FTP. In some cases, it was other means of connecting, such as VPN or other types of connections. But once we get the data up there, then our remote analysts, wherever they're at, they can apply tools that are in the cloud and start to do some analysis, make recommendations, and actually store reports and other types of information right there. And then we also encourage, two-way communication here between the end user and the analyst. So that's kind of how we started out, and this is evolving. I'll talk a little bit more about where that's going here in the next few slides. Part of how we did this was partnering with other companies, such as Seek in this particular case, where we were able to, kind of build an environment where we're connecting our local service people, Fisher, the vendor, and the customer all together using software and other tools in order to not only enable data visualization, aggregation of data from multiple sources, but also some collaborative environment so that people can look at the same data, work on the same data. So since we're relatively new to this, we've actually got a pretty small number of analysts that are doing this remote monitoring service, probably 6 in North America. And they all live in different places. Well, there's 2 of them in Marshalltown, the rest of them are scattered around North America. But with the tools that we're using here, with the help of Seek, we can actually collaborate, almost like having a live meeting or something like that. So that's been quite helpful. And we're looking at different ways of deploying these tools, where we could have software residing on premises for the customer, or remotely in the cloud, or what we think is probably the right answer is both. And there's opportunities to have the analytics running in multiple locations. And I'll talk about that a little bit more in another slide or two. I guess one other, if I back up one other thing that we find value from this on is, we see a tremendous value to Fisher beyond just this extra service opportunity or the revenue that we can provide. And that's getting real feedback, like I think Matt talked about from Ingersoll Rand, is getting real feedback on how our valves are actually performing, what's actually failing, what do we need to work on when we're designing new products. We've always got a funnel of design issues or design projects coming up into our next generation products. If we get actual feedback from the field, we're going to know exactly what are the biggest issues in the field, and we can make sure that we address those in our design products. So we think there's a lot of benefit beyond just this extra revenue stream. So some of the benefits that our end users are seeing through some of our pilot opportunities and some of the contract monitoring that we're doing now is one, the asset management tools and equipment that they've purchased already are finally being used as intended. So we think there's some value coming from that. There's been a lot of cases where the end users have purchased the extra equipment, purchased extra capability, and not really gotten the value out of it. So we think we're providing some help in that way. Health data is collected way more frequently. So when we go on site to do some of this remote monitoring setup, we actually configure and schedule tests to run on a fairly frequent basis. And actually, in some cases, we're collecting data as little as once a week. And that doesn't sound like it's very often. It's far from streaming real time. But compared to the current state of the art and how a lot of our customers were using the tools previously, it might have been once a year, maybe a couple times a year. So we're light years ahead of where a lot of the customers were with some of the diagnostic data for valves. And we've got plans to increase that to being much more frequent than even once a week or a few times a week. So kind of taking baby steps there, but it's been quite useful. The expert analysts are applying new methods for valve health assessment. So instead of just opening up a software package that communicates to valves, looking through data sets, looking at graphs, looking at analyzed data, we're employing new methods of looking at the data. Long-term time series of performance data for a valve, for example. Looking at parameters on different axes, different time scales. All of that's been quite useful, and we're learning a lot by looking at data in these different ways. Some of the big things that we've helped with through some of the pilot opportunities and the monitoring contracts is really avoiding downtime or shutdowns through early fault indication. So, all of our customers go through some downtime, some turnarounds, but the big issue is when those are unplanned or unscheduled. And so if we can, identify a problem while we're operating, and then when a downtime, a shutdown or a turnaround comes up and we can address those problems during that time, we have eventually avoided some potential unplanned downtime. And we've had some pretty good results with that here fairly recently, actually. One of our customers that we worked with is a paper manufacturer in the Midwest, and in a short period of time we actually captured 2 different issues that we were starting to anticipate on actually one was on each paper machine that they have. And by avoiding a shutdown and correcting these during a planned outage, they estimated that we saved almost $300,000 just in lost production. And that didn't count the paper roll break and all the cleanup that has to do with that, the valve repairs and several other things. So some pretty good credit there for just trending some parameters and noticing that things were starting to get out of whack. And in those particular cases, what we realized is we're going from generating alerts and alarms or looking at diagnostic data like we've done for a long time, and we've kind of gotten to the business of trying to predict the alerts. And when we can do that, we're telling the customer they needs to fix something well before the alert is actually activated, but we can definitely start to set some trends and see that we're going to cross this alert point at some time, and that gives a lot more time to plan the downtime, order parts, line up the service, things like that. And in some cases, we're seeing these weeks and sometimes months in advance of the alerts even, so it's been quite useful there. So some of the lessons learned, when we went out and started talking to our customers about some of these things, our traditional way into a lot of these sites is talking to the operations people, the maintenance shop, instrumentation, kind of the OT side of the house. And they were often afraid to engage the IT folks. Generally the answer was, I kind of like what you're talking about. We're interested in remote monitoring, but that means I have to talk to IT, and I'm really not interested. That sounds like a lot of work. And sometimes the conversations would just plain stop right there. As we started talking to more and more people at the upper levels of management and started talking to the IT departments, we started realizing that the IT folks actually get it, and they understand that there's a lot of benefits that can come from IoT. And so sometimes the two sides of the house weren't talking well together, and often if we would get into the same room, we could actually solve some of those issues. And actually, Brian and Seek have helped us with that in a couple different cases, just being able to get the right people in the room, talk about how we're going to handle the security, and that's really made all the difference here, especially more recently. Another thing we learned is trying to develop an all-inclusive solution is tough. If you say we're going to roll out an IoT product or service, it kind of seems to imply that you're going to have all these analytics built right in, everything's going to be automatic, plug and play, and it's just going to work. And it's tough to get there all the way because you really don't know what you don't know. You got to start collecting the data, start looking at it in different ways, and using some different tools or some different mindsets than you had in the past can really open up some new ways of looking at the information and making some better decisions much earlier than we could in the past. We've also found it, especially for valves, reliability, the whole message of reliability and uptime is an easier sell than some of the incremental performance improvements. And we've talked about that for a long time. If you can take a control valve, improve its process control, you lower variability, you can operate closer to set points, and that adds to the bottom line. Everybody understands that, but it's also difficult to prove it or to quantify it after the fact. It's tougher to figure out what your contribution was to that and how it actually helped the customer out. They all understand reliability, though, or availability when the valve shuts down and causes the whole unit to shut down, because then you've gone from some level of performance down to 0 instead of some level of performance to plus 1% or plus 0.5%. Much easier for us to talk to our customers about that. And finally, our end users do like technology. They like all the stuff that we're working on, but they really buy solutions at the end of the day. And so that's what we're trying to provide with the remote monitoring service. So we've got several planned enhancements. Like I say, we started out slow, and we have heavy involvement on the human side, which means that for the most part, we have a valve analyst logging in, looking at this data, making decisions, recommendations, and reports. So heavy on the human side right now. But our plan really is to learn from that experience and start to add automation where it makes sense. So there's a lot of things that we've already learned that we know we can build algorithms around, and we can start to automate some of the analysis and maybe even start to push that on site to a machine that does some of the analysis locally. We've learned that there's a lot of room for improved data visualization. So our current software platform is just not built, and when I say our current software platform, I mean the software that talks to valves to do calibration, configuration, diagnostics, things like that. Great tools, lots of capability there, but it's not built for a plant-wide or an enterprise-wide monitoring solution. And again, that's where we had to bring in other help, such as Seek and different types of tools to be able to look at the data to be able to make that a viable surface. So what we look at is different ways of looking at the plant or many plants across a lot of valves. Can we quickly decide which ones are fine versus which ones actually need some attention? Instead of having to look at 100 valves, maybe there's 20 that we really need to focus on. You're going to make better decisions when you do that. Taking the data and putting it in time series. And then when I say time series, we're not talking about a 20-second test or a 5-minute test like most valve diagnostics are. We're talking about years. Can we look at these over the last several months, last several years, and see how things are changing? Are things trending up? Are things trending down? Are they behaving about the same? And wrapping analytics around that. Also, we look at different types of scatter plots, just X, Y parameters, a couple different values that we collect. Add the third dimension of time on there, which you'll see there's blue, orange, and gray dots there. Those are different time frames. So you can look at the most current data, compare that to how that particular valve has operated in the past. That tells our analysts a lot about the health of the valve and probably gives them some indication about, is it heading in the wrong direction or still behaving okay. So like I mentioned before, we're interested in having, probably an on-site solution from an analytics platform, but also the remote solution. And what that really allows us to do is kind of get into a do loop of developing our analytics. So, when our analysts see something one time, they learn something from it. They see it 4 or 5 times, we should figure out how to automate it. We can push that down to the on-site application. And then if we get really good and can compress it enough to put it into the instrument, that's the ultimate goal. And I think that'll continue to evolve in that way. So just some real quick recommendations based on our journey. Really what made the most sense is to just get started. Not necessarily wait until you have an all-inclusive solution that has everything all figured out and all the analytics there. We started out with heavy emphasis on the human analysis. But we're finding that technology is quickly evolving in this space, whether it's communications or processing or sensing, all these different types of things that are helping us clear the hurdles that existed in the past. So it's making it much easier to get to. We also realized that you don't necessarily need high-powered analytics to get the ball rolling with IoT. Start collecting the data. Again, you don't know what you don't know. you'll learn what you need to look for as you get going. The new visualization techniques can be very powerful. We've had lots of luck for that. And really what we're doing is we're learning from the data and we're starting to make incremental improvements. So we see this as kind of an ongoing process, and we'll continue to refine that as our next generation products come out. And part of why we're doing all of this is to try and build our IoT strategy into future products and services. We've already got that with the services side, and our next generation products are being designed with this in mind. Does that mean different types of wireless communication, more sensors on valves, actuators, positioners? And the answer is going to be all the above.